Hello everyone and welcome to We Meet at Digital Days. My name is Marie-Therese Kohl and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Wireless Power Transfer enables IIoT. We cut the cord. Our speaker is Jem Som. He will hold the presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentations. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. The presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our event. You will receive the link to the presentation in the next few days. Also, the recording will be available at our website shortly. But now, I will hand over to our speaker, Jem, and I wish you an exciting presentation.
So, hello and welcome to our session Wireless Power Transfer Enables IIoT. We cut the cord. My name is Jem, as mentioned from Marie, and welcome to our session. So, first of all, I would like to thank some colleagues which helped me to realize this. This is really important for me because without Miro, Adi, and Daniel, I'm not able to show you today this great application and solution which we have today here on my desk. So first of all, what I would like to show you today is different kind of applications which are able to use 200 watts. So there are a lot of applications today which are usable. For example, you have a lawnmower in your garden or in the backyard, or you have some drones or any kind of power tools, or maybe your laptop. Also some robots which are used in agriculture, or just a simple e-scooter. All of these different kind of applications are in the range between 50 and 200 watt. Mostly, or let's say all of them today, are really using any kind of plugs. There may be some kind of, let's say, power tools from different companies which are able to do some kind of uh, wireless power at their power tools. But in the major part, all of these, for example, driving alone to a charging station, there are contacts and the battery will be charged. So how to do that? In this case, I would like you, first of all, to show you the basic. At the basic, for example, we have our wireless power development kit, which we developed together with Infineon. As Infineon is we are using Infineon's controllers, MOSFETs, and gate drivers. At this kit, you can, if you open the box, you have different kind of inputs. I would like to mention here that this product is the product of the year 2019 and as an innovator 2019. So we are very proud of this. So what are the benefits? The benefit for first of all is if you're transferring energy from the transmitter to the receiver side, we have a current profile which is almost sinusoidal. This is very important for the EMI behavior. The second is by changing the frequency, you are changing the output voltage. This can be regulated. At one point, we have an automated mode, which will be done by the regulation loop, which is a feedback loop from the receiver to the transmitter side, or you can do it manually by changing the frequency. The second point is this system is scalable. you can use it from 10 watt up to 10 kilowatts. For sure, you cannot use these small boards for 10 kilowatts. You have to scale them up additionally. But also here, we can help you. The MOSFETs which are used here, they are crossing at 0 point. That means we can achieve a very high efficiency, over 90%. So this is very good. As you can believe, all of these losses which are going out of this will be warm or heating up your device or application. As mentioned in the beginning, also it's scalable for different voltages and currents. So in this case, for design kit, we have an input voltage range from 18 volt to 24 volt, and from, for sure, 0 up to 10 amps. And if you would like to, for example, use a different voltage in your input for higher voltage or lower voltage, also here we can help you to adjust the schematic. Additionally, a data transfer in the basic system from the receiver side to the transmitter side is included. So you are able to transfer for additional any kind of button or LED signals from one side to the other side. You can see here in a very small schematic at the right end in the corner, you have at the transmitter side a full bridge, and at the receiver side an active rectifier. This is the load. Here are the coupling system of the coils and the input voltage. Very simple. All these informations you can find on our website at the for this application node with the ending ANP070. The system looks like that. You have on the left-hand side the transmitter, on the right-hand side the receiver. Important, always you have to use a load. In the middle, two coils with a distance of 6 millimeter, just as an example. For sure, this is just a picture. The wireless power coils must be placed coil by coil, otherwise it will not work. As mentioned, you can control by the data transfer buttons LEDs, which are lighting up on the transmitter side or on the receiver side. If we have some measurement points, for example, directly at the coil here, or also on the board to measure the data, for example, if I'm pressing a button, how this looks like and how can I do this? If I have an oscilloscope and I will pushing the button at the receiver side, I have a data input, which looks like this, for example. It will be ASK, amplitude shift key, modulated on top of the sinusoidal power. And on the transmitter side, it will be demodulated and the data is on the transmitter side. So we are working here in an in-band data communication. We have a lot of questions how I can get the software. Important is everything which you are buying here is, and if you in the website you can find everything like the software, the GABA files, the layout files, the manuals, everything you can download. And how you can find it? Quite easy. You can go to our website we-online.com/wireless power. Then you go to the 200 watt kit, and there is a section for links. At the link site, you can find align application notes and current firmware. If you click on it, you will be forwarded to the ANP070 website with the application note, where you have to register yourself. Second or thirdly, you will receive an email to confirm your email address. After that, you can use directly the link to download your files. This looks like that. And then you will receive the whole software package for the transmitter and receiver side. Additionally, you have to install the Dave software environment from Infineon, and you have to buy a debugger. With the debugger, you can connect to your board at the debug interface, and then you can program, reprogram, or manipulate the software as you want. As mentioned, the input and output voltage of the system can be changed by themselves. Important is here that the input and output voltages, we can help you on this. As you know that a lot of applications, example the e-bikes, e-scooters, they are using batteries with 48-volt input, for example. In this case, we help you for that, as we have a predefined BOM change for 48 volts, and please get in touch with us and we can help you there. Additionally, all files like the GABA files, the GABA files for sure, but also schematic and layout files, we can give you in Altium or in Eagle files, and we can also give you the BOM, we can give you the software, everything else, that's for free. Additionally, if you would like to go over the 200 watts, for example, we have a new part, which is the ending 311 in the end, and this is a bigger coil. With this bigger coil, you're able to transfer up to 400 watts. So we have a lot of added values which you can get from us if you are using this design kit. Additionally, on that, last month we are very proud of the new member of this family is the LCD board. This LCD board have additionally to the system some benefits. First of all, you can have an end-to-end IoT system implementation. What is the meaning of that? I would like to show you later on. The LCD board is an add-on board to the 200 watt kit plus sensors, which is giving you additional information about the system on an LCD board. With that, you are able to download a new software and which is able to do a bidirectional data transfer from transmitter to receiver side. As mentioned before, at the basic, you have the possibility to transfer from the receiver side to the transmitter side. That means we have as a basic our 200 watt kit, which includes the transmitter board and the receiver board. At the receiver board, you can connect via I2C a sensor board, and via UART interface, you can connect the new LCD board. For example, the WSEN PADS board, which is a temperature and pressure sensor. For sure, don't forget always to connect the load. Our new board, EMP LCD in the ending, you can find it on our new website. It's weonline.com wireless power/LCD. The LCD board looks like that. I just make a very rough picture here. You can see the informations which are shown, while like the voltage input and output, current input output, the calculated power, efficiency, in this case, temperature and pressure. On the board, we are trying to use a lot of Würth Elektronik passive components for sure. The LCD, as mentioned, are populated with a lot of WE components. The LCD board is again programmable. That means we have a debug interface. We have again an XMC Infineon controller, which can be programmed. All these is absolutely, again, for free. All these data like the BOM, the GABA files, the layout files, and the firmware, which is needed to reprogram the transmitter and receiver board and the LCD board, is available for free on our website. We have different kind of software, this I have to mention, if you are using a sensor or if you are not using a sensor. As mentioned before, different kind of applications, this can be used. For example, industrial applications, you would like to measure the battery temperature on your e-bike, or you want to get additional informations out of your tooling, mechanical tooling, or in a climate chamber, for example, the temperature. This is available and you can order it now, and also you can have a look on our WE online catalog. So how to download the software for the LCD board? Again, very short and very easy. Step 1, go to our website. Second step, just click on new firmware for these boards. There will be a pop-up window appear as a zip file and you can download it directly. In this zip file, please take care, all data is included, so you can see it's a quite big file. The system, it looks like in this way. I don't know if the camera is good enough to show this on my desk today, but you can see this system on the picture I have here on my desk. So we have the receiver board with the sensor, we have our wireless power coils, we have the transmitter board, LCD board, the wireless node, and the Wi-Fi module. If I'm doing that, I'm able to create data. This data will be created from the temperature sensor. The temperature sensor is sending the data in band over the UART, over the wireless proprietary protocol to the Wi-Fi module. The Wi-Fi module is sending this, for example, to a dashboard. And then you can see this curve. In this case, I would like to jump to a live side, and you can see here the temperature and pressure of this module. So if I'm changing the temperature, for example, here, you can see that this is also changing. If I'm going to the load, which is getting warm, for example, you can see that the temperature rise is alive. Going back to my presentation. So how is the data transfer? You can see we have I2C sensor interface from the sensor board. The data will be in-band transferred, as I mentioned before, with the oscilloscope graph. The data will be demodulated here and sending out from the XMC controller over the UART interface to the LCD board. At the LCD board, there is a data path through. So one side, the XMC controller is changing the UART protocol to an SPI and sending again the same signals, UART signals, to the wireless node with the same data transfer rate. The wireless node at the proprietary protocol is sending this data by 2.4 gigahertz to the Wi-Fi module. It is possible to connect up to 65,000 different nodes. At the Wi-Fi module, we are just sending it standardly with a standard Wi-Fi data transfer, the data to the cloud, or you can send it to anywhere else. And then at a smartphone, a tablet, something like that, you can have a look on your dashboard. All of these systems you are able to get from one hand. That means, well, the Würth Elektronik will help you to integrate, to realize really an IIoT system. We have from the beginning, from the sensor data up to the showing the data on a screen. And all these will include the different product and business units in our company. I'm really proud of that, to showing this the first time in your company time. Of course, we have also a book for wireless power transfer, which gives you the basics for the wireless power transfer system, and you're for sure welcome to order them in our web. If you need additional help for this kind of very not so easy but quite complicated system, first of all, you can download everything on our website. You can just go to the Wireless Power website. You can download the app notes, the schematics, the Gerber files. You can download also for free the software. Additionally, you can contact our technical sales guys, which are locally in your nearby. Additionally, you can send us an email to the Wireless Power hotline with the subject 200-watt kit, and we directly know what is your request. Additionally, for sure, you are able to contact our guys from the wireless connectivity department, which are responsible for the wireless node and the Wi-Fi modules, and will help you to integrate a kind of dashboard if you would like to see the data on your laptop or smartphones. I would like to thank everybody to this very short webinar, and to give you the opportunity now, and if you have any kind of questions, and I'm very happy to help you. And I would like to
Yes.
Hand over to Marie.
Thanks. Thank you, Tim, for your interesting presentation. As you already mentioned, we would like to turn now our attention to your questions, and you can just enter them in the chat function in your webinar control panel. So feel free to ask. Jem, maybe one first question. What is the maximum power to transfer with the development kit?
So the maximum power with this kit, which we have here in our desk, for example, today in the box, we have a 150 watt power supply. The kit itself can transfer 200 watt, as we use a smaller power supply in the box, because otherwise we have to cool down our coils actively, and we don't want to do that because of the safety reasons. But in general, this small boards, we have a size of 80 by 80 millimeters, are able to transfer a power up to 200 watts.
Okay, perfect. Thanks. And another question is, where can I see the data at the cloud?
So the data at the cloud, for example, you can see, as an example, so I'm using the data here, which I've shown you at it's an own, I don't know, the Microsoft page, which we built up for testing possibilities. If your own company or you have an own website cloud service, you can use, and we can help you to integrate this interface, that you can have this on your own servers, as we are not a, let's say, service provider. We helping you to get available the data, any kind of technology. So
Okay, thanks. Another question is, what is the maximum distance for effective energy transport?
okay, let's say the question is, it's a very good question. The point is just what is effective for the high efficiency. As better the coils are connected, maybe I can just show it here. If I have a misalignment with my coils, which you can see here, then the data transfer, and the power transfer is not able to do. The best case is we have a distance of 1 to 2 millimeters. So we need a little bit distance. If more than 10 millimeters is not possible, so as better the coupling is between the coils, as better the data and power transfer it is.
Okay, perfect. Thanks, Jem. I would say if there are any questions left, we will answer them via email afterwards. But for now, we are finished with this presentation. Thank you very much for your attention, and I hope you enjoyed our presentation. The next and last presentation topic is EMC interference search and measures. So this presentation will start at 5 p.m. See you there and enjoy our digital days. Goodbye.
Thank you. Bye-bye.